Now we are going to study question from March 2011 exam question 4 and same question asked in April 2016 question. Okay, everyone give the heading. March 2011 question 4 and same question asked in April 2014 question 1. Okay, everyone give the heading. This is very quite interesting question, guys, and little bit difficult also. This is not that much easy question. Now try to see the scenario, what the question want to say. A vessel is traveling in due west. Okay, one vessel is traveling in which direction, guys? It is going in west direction, due west. At which speed? At 18 knots, guys. So first vessel direction is what? First vessel speed is what? 18 knots. It is going in which direction? It is going in due west. Okay, try to see the scenario. It sights another vessel 8 nautical miles away in a direction of 20 degrees south of west. Okay, try to see the sign point here. Okay, now I am going to draw the space diagram here. First of all, here also I am going to draw space diagram as same as the previous question. So for drawing space diagram, everyone try to see the scenario here. So first of all, axis. See the drawing. Always try to draw the bigger drawings. So this is what a north direction, this is what a south direction, this is what a west, and this is what a east direction. So suppose this is what a initial position of what? This is what a suppose initial position of what, guys? Initial position of what, everyone? Initial position of what? First vessel. This is what? Initial position of first vessel. Try to see this scenario. This is what? Initial position of first vessel. So what is happening, guys? A vessel is traveling. So first vessel is traveling at what speed? A vessel is traveling due west, in due west direction at 18 knots. That is its speed. That is velocity. Sights another vessel, second vessel, 8 nautical miles away. Okay, see here it is not observed in dead ahead direction. Sights another vessel. So first vessel observed the second vessel in which direction? In how much distance, guys? 8 nautical miles away. 8 nautical miles away in a direction 20 degrees south of west. Try to see the scenario here. In which direction, everyone? 20 degrees south of west. How much? 8 nautical miles away. See the point here. So here I am going to draw one line from here. See this line, everyone. Try to observe this line. Understanding this line is very, very important to us. One minute, guys. This is little bit tricky question. So drawing has a crucial role here. So this is what, guys, this is what suppose initial position of what? This is initial position of first vessel. Everyone try to see the scenario here. So 20 degree what? 20 degrees south of west. So this direction is what? What will be this direction, everyone? This is what? 20 degrees south of west. South of west. And how much this distance? 8 nautical miles away. Guys, are you getting my point? Try to see the scenario here. Very, very important. Suppose we are going to make first vessel relatively stationary. What we are going to do? We are going to make first vessel relatively stationary. Try to see the scenario here. You got the meaning of what relatively stationary? Relatively stationary means where is observer? Who is the observer? Observer is the first vessel. What is the meaning of what? Relatively stationary? Relatively stationary means what? Observer is on the first vessel and it is observer is observing the second vessel. Now see the next scenario here. What the next scenario, next question want to say? What the next question want to say here? So next sentence what want to say? 30 minutes later, second vessel is 3 nautical miles away. After how much time? After 30 minutes, guys. After 30 minutes, later second vessel is 3 nautical miles away in a direction of 50 degrees south of west. In what direction, guys? 50 degree south of west. So angle and how much distance? 3 nautical miles. So see the scenario here. So here, see the scenario here. Everyone, understanding this drawing is very, very important to us. So here, so this will be what? So see this position, everyone. Observe this position. So this will be what, guys? What will be this position indicate, everyone? What will this position indicate? What will this position indicate? This will be what? So this distance is how much? 3 nautical miles. This angle is how much? 50 degree. Guys, are you getting my point? And what will this position indicate? What will this position indicate? Position of second vessel after 30 minutes. What will this position indicate? Position of second vessel after what? After 30 minutes. Try to see the point here. So here we will say this position as point P. This position as a point Q. This is what a position point P. This is position point Q. So what is the meaning of point P, guys? What is the meaning of word point Q? Point P, first of all. Point P means what? Initial position of what? Initial position of what? Initial position of what? Second vessel. And what is meant by point Q? What is meant by point Q? Everyone. Position of what? Position of second vessel after what? After 30 minutes. Okay, guys. Everyone, this is visible to you? Okay, guys. Second vessel after 30 minutes. Anyone have any doubt in this discussion? Try to see the scenario here. Now the next point will be what? So what we guys observe this drawing. Carefully observe this drawing. Understanding this drawing is very, very important to us. Now what is, if you observe this drawing carefully, see, our first vessel is what? Here, and we make it as a relatively stationary, and initial position of first second vessel is here. After 30 minutes it is here. So if you join these 2 points, guys, if you join these 2 points, what will happen, guys? If you join these 2 points, everyone, if you join this point P and Q, suppose if you join this point P and Q, what will become, everyone? This will become what? Relative velocity or relative path? Okay, see, because this is a space diagram, guys. On space diagram, it must be what? So here, if we join these 2 points, P and Q point, what will this become, guys? This will become what? Relative. What this will become? Relative path of what? Relative path of what? Second vessel. With respect to what, everyone? With respect to what? With respect to first vessel. Okay, guys, are you getting my point? Very, very simple discussion. Not that much difficult. Anyone have any doubt in this drawing, guys? Observe this point. So point P means what? Initial position of first vessel. Point Q means what? This is a point Q. Guys, I make it properly, so it is visible to you properly. So this is a point Q. Any doubt in this discussion, guys? Observe here. And what is the name of this figure, guys? What is the name of this figure, everyone? Okay, very good. Okay, what is the name of this figure, everyone? Name of this figure is what? Space diagram. And what is the meaning of space diagram? In space diagram, one vessel is stationary, another one is moving. Stationary means on that vessel there is an observer. Anyone have any doubt here? Now what is our target here, guys? What is our target in A part? Very simple, guys. Very simple. What is our target in A part? Try to see the scenario here. What they are asking us in the A part? Distance of nearest approach. What they are asking us here? Distance of nearest approach between the 2 vessels if they maintain their present course, present speed and course. Speed and course means its value and direction remains same. Okay, guys. So distance of nearest approach, and how to get the distance of nearest approach, guys? So from this point we are going to draw a perpendicular line here. Try to see the point here, everyone. Observe the things here. So from this point, what we are going to do? We are going to draw a perpendicular point, and this point is what? Our R. And what is the meaning of R? R denote what? What R denote, guys? What R denote? Point of nearest approach, and this D means what, everyone? What is the meaning of D? D means what? Distance of nearest approach. So in A part, our target is what? What we have to find out? Distance of nearest approach. Very simple discussion, guys. So distance of nearest approach means what? We have to find out D. So this is what our target in A part. Any doubt in this discussion, guys? Everyone got the drawing? Now, next point, guys. Next point is little bit interesting. So see the scenario here. Everyone, what will be this angle, guys? See this one, blue one. What will be this blue angle? What will be the blue angle, everyone? 30 degree. This blue angle will be what? 30 degree. So now, guys, if you want to find out this D, everyone try to see the scenario. If you want to find out this D, so we need this angle theta. What we need, guys? We need this angle theta. So see the point here. Huh? This T, theta, opposite is D, hypotenuse is what? Opposite is D and hypotenuse is what? 8 nautical miles. Try to see the scenario. If we need a distance of nearest approach, what we need? We need the value of theta. And for getting theta, what we are going to do? First of all, we are going to find out PQ. What we are going to do, guys? First of all, we are going to find out PQ. See the scenario here. Because for getting this theta, we should have a value of PQ. So for getting PQ, we are going to use our cosine rule. And when to use cosine rule, guys, we already discussed. Whenever we have an angle, this angle 30 degree, and we know its adjacent side, and we want to find out opposite side. And what is opposite to 30 degree, guys, here? On this triangle here, I will make this center point as a O point. Suppose we consider OPQ triangle. Here we consider what? OPQ triangle. Let's try to see the scenario here. So here, by what, everyone? By cosine rule. From cosine rule, what we will get, everyone? From cosine rule, what we will get? We will get the value of PQ. So PQ is equal to what? What will be the PQ? Under root of, everyone? Under root of what? And for your reference, I am writing here in bracket triangle. This symbol means what? Here I am writing in bracket triangle. Which triangle, guys? We are considering OPQ. So that you should get during the revision. Triangle OPQ. So PQ is equal to what, everyone? PQ is equal to what? Under root of 8 square plus what? 3 square minus 2 into 8 into 3 into what, guys? Into what? Cos of 30. Everyone getting my point? So in this way, we will get the value of PQ. So everyone, please do the calculation and tell me the value of PQ. Everyone, please do the calculation and tell me the value of PQ. Under root of 8 square plus 3 square minus 2 into 8 into 3 into what? Cos of what, guys? Cos of 30. How much value, everyone? 5.6063 unit. What will be the unit of PQ, everyone? Nautical miles, guys, because it is a distance here on the space diagram. So unit is what? Nautical miles. So we got the value of PQ. Now why we calculated PQ, guys? From PQ we will get the value of theta. From PQ what we will get? We will get the value of theta. Try to see the scenario here. So we are going to apply now by sine rule. Which triangle we are going to apply sine rule? Triangle. Again OPQ, guys, same triangle OPQ. This triangle is visible to everyone. See, this meaning of this symbol means what? Triangle, everyone. So here this triangle OPQ. Okay, guys, are you getting my point? Try to see the scenario here. So by sine rule. So what we have to find out? Theta. Opposite to theta, which side is here? Opposite to theta. In this drawing, guys, opposite to theta, which side is here? On the triangle OPQ. 3 nautical miles. So 3 by, everyone observe the things. 3 by what? Sine theta is equal to what? PQ. We have the value of PQ. So you got the point. Why we calculated PQ? So opposite to PQ is what? Sine 30. So sine theta will be equal to what, guys? What will be sine theta, everyone? What will be the sine theta? 3 into what? 3 into sine 30 divided by what? PQ. So sine theta is equal to 3 into sine 30. What will be the value of PQ, everyone? 5.6063. Check it out. I have done any mistake or not? 3 into sine 30 divided by what? 5.6063. 0.2676. So what will be theta, guys? Sine inverse of 0.2676. So what will be the theta, everyone? Sine inverse of 0.2676. Okay. 15 point how much, everyone? 15.5215 degree. So we got the value of theta. And from theta we will get, see, observe this one. Observe this triangle OPR. Observe this triangle. Which one? OPR. So this is what? D means what? Opposite. 8 means what? Hypotenuse. So what we can say? Opposite and hypotenuse. What will be the relation between opposite and hypotenuse, everyone? What will be the relation between opposite sine? So sine theta is equal to what, everyone? Sine theta is equal to what? D by 8. So D is equal to what? 8 sine theta. Everyone got the point? Why we calculated theta? And why we see, from PQ we got the value of theta, and from theta we will get the value of D. Okay, everyone, see the point, why we are doing this calculation. So D, 8 into what? Sine of what? How much theta? 15.5215. So what will be the D calculation? 8 into sine of 15.5215. How much, everyone? Distance of nearest approach 2.1408 nautical miles. See, very simple discussion, guys. See the scenario here. Is this difficult, guys? Only understanding that drawing is difficult task. Otherwise, things are very simple here. Understanding this drawing, we have made the one vessel relatively stationary. Means what? Who is the observer? Observer is here. Observer is on this one. First vessel is observer. Then first vessels observe the second vessel at what distance, guys? 20 degree. South of west, 20 degree. So we got the initial position. After 30 minutes, second vessel is what? 3 nautical miles, 50 degrees south of west. So here we got the second vessel, means position of the second vessel after 30 minutes. That is what? Point Q. Point P and point Q. Guys, see the scenario here. Point P and point Q. Then if we make this one as a relatively stationary, so if we join these 2 points P and Q, what we will get? What we got, guys? Relative path of the second vessel with respect to first vessel. So here we got what we got, guys? We got the relative path. And once we got the relative path, so if we drawn perpendicular line from the point O, from this one, then we will get what? What we will get? Distance of nearest approach. See, very simple task, guys. So one of the easiest chapter, or in other words, one of the difficult chapter also. If you got the concepts here, you don't have to memorize anything. Means no theory for this chapter, guys. Just basic concepts, trigonometry. That is the basic thing. We need a trigonometry in every chapter here. No special formula for here. Just two to three basic concepts here. Sine rule, cosine rule, sine theta, cos theta, tan theta, and finish this chapter. Nothing is there. Now, guys, what you have to do before going further? We need, now guys, for the next part, we need the direction of relative velocity. What we need? We need the direction of relative velocity. So for getting the direction, what I am going to do? From this point, everyone try to see the scenario. From this point, I am going to draw one dotted horizontal line. To get the direction of relative velocity, from this point, I am going to draw what? What I am going to draw, everyone? Observe this one. I am going to draw, this is what? One horizontal line. And why I am drawing this? See, whatever the direction of relative path, Same will be the direction of relative velocity, and we need a direction of relative velocity in the next part. So here I am going to draw this one, this dotted line. Then I am making this angle as what? Theta 1. What I am making this angle as theta 1. So this theta 1 means theta 1 represent direction of relative path, and whatever the direction of relative path, same will be the direction of relative velocity, guys. We have studied these things in previous question. Now, so here this is what our theta 1. This is what our theta 1. And here, guys, try to see the scenario. My question for all of you, guys, what will be this angle, guys? See this one. Angle of 8 nautical miles with respect to horizontal. Guys, what will be the angle of 8 nautical miles with respect to this black one? Guys, this black one is visible to everyone? This one. How much, guys, that angle? Everyone. How much, guys? 30, 50, 20, 60, 70. How much? 20 degree. Option B. 30 degree. Option C, 50 degree, or none of the above. Which one will be that angle, guys? Which one this angle, everyone? See, whatever this angle, guys, say 20. Yes, 20 degree, correct, guys, very good. So this angle will be what? What will be this angle here? So this angle will be what, everyone? What will be this angle? This angle will be what? 20 degree. Anyone have any doubt in this 20 degree? So now, guys, before going further, why we don't need this theta 1 for the A part, but we need all these things for the B part, and so our drawing should be complete properly in format. So in the beginning itself I have drawn this theta 1. So this is 20 degree, this is a theta, this is a theta 1. Theta 1 will give you a direction of what? Theta 1 will give you what, guys? Direction of relative velocity. So before going further, guys, before going for the B part, what you have to do? You have to draw this space diagram first. Show the properly everything. Show the what is the meaning of point P, point Q. Then our target for the A part. Please, everyone, complete all these things. What they are asking us in the B part, guys? Course and speed of the second vessel. Okay, what is the meaning of course? Course means direction. So in B part, what they are asking us, guys? Course and speed of the second vessel. Speed of the what, everyone? Speed of the second vessel. This is what our target here. So what is the meaning of word, guys? Course. What is the meaning of word course? Course means what, everyone? Course means direction. And what is the meaning of word? Meaning of word means what? Magnitude. What is the magnitude here? Now before going further, guys, what we are going to do? We are going to draw everyone? So before going further, what we are going to do? We are going to calculate we are going to draw the velocity vector diagram, and we are going to calculate relative velocity. See the scenario here. First of all, what we are going to do? We are going to draw the velocity vector diagram. See, simple is velocity vector diagram. So for drawing velocity vector diagram, so in the question, for the first vessel, what they have given us? For the first vessel, what they have given us, guys? They have given us in the question. Observe the question, guys. What they have given us in the question? First vessel is what? How much velocity of first vessel? 18 knots. In which direction? It is in what? In due west. First vessel is in which direction, guys? Everyone? It is in due west. So this is about first vessel. Now we are going to draw what we are going to draw? We are going to draw what we are going to do, guys? We are going to draw the velocity vector diagram. What we are going to do? We are going to draw the velocity vector diagram. And how we are going to draw the velocity vector diagram? Try to see the scenario here. Very simple discussion, guys, not that much difficult. See, first of all, we are going to draw our reference axis. So this is what try to see the point here. Don't write anything, don't do anything. This is what? North direction. This is what? South direction. West. And this is what? East. Okay. Now everyone, what is the direction of first vessel, guys? First vessel is in due west. So here I am going to show V1. So due west. So this is what our, try to see the point here. Huh? So this is what? This line indicate what? V1. It is in due west direction. Guys, see the point here. Huh? Everyone. So V1 is in due west direction. Now, what will be the value of relative velocity here, guys? What will be the value of relative velocity? What will be the value of relative velocity here? Everyone, what will be the value of relative velocity? Relative distance over time. Okay, so now guys, relative distance over time. So what will be the relative distance here? What will be the relative distance here, guys? What will be the relative distance here? Everyone, what relative distance we can take here? See, whatever the distance we have known on the relative path, PQ. So PQ we can consider as our relative distance. And what will be the value of PQ? We calculated in A part, guys. PQ value we calculated in A part. And how much value we can? 5 point. How much we calculate? 5.6063 nautical miles. So we calculated, guys, relative distance. What will be the time? So how much time required by the second vessel to cover this relative distance? 30 minutes. Okay. So time is what, guys, for that one? 30 minutes. They have given us in the question. Huh? Everyone, try to see the scenario here. So 30 minutes. So 30 minutes means what? How much hour, guys? 30 minutes means how much hour? Guys, for relative velocity to get in knots, we need a time in hour. So 30 divided by 60. So 30 divided by 60 hour. So it means what? So how much, everyone? 0.5 hours. Okay. Everyone getting my point? So we got the value of time. From that one, we will get a relative velocity, magnitude of relative velocity. Relative velocity means what? Relative distance, everyone. Divided by what? Time. Try to see the scenario here. Very, very important discussion. So relative velocity will be equal to what? Relative distance 5.6063. 5.6063 divided by 0.5. So what will be the relative velocity, magnitude of relative velocity, guys? So please everyone do the calculation with me. 5.6063 divided by what? 0.5, how much? 11.2126 unit knots. So we got the value of magnitude of relative velocity. Now next thing is what? We got the magnitude. Second thing is what? Direction. What will be the direction of relative velocity here, guys? This theta 1 indicate whatever this theta 1, guys. See this on this drawing. This theta 1 indicate what? Direction of relative velocity. So to get the direction of relative velocity, we should have the value of theta 1. So theta 1 will be equal to what, everyone? What will be the theta 1, everyone? What will be the theta 1? 20 minus theta. Theta 1 will be what, guys? 20 minus theta. So 20 minus theta is how much theta we calculated in A part? How much value of theta we calculated, everyone? 15.5214. So what will be the value of theta 1, everyone? 20 minus 5214. Please do the calculation with me. 20 minus, how much, guys? 20 minus 15.5214. How much, everyone? 4.4786 degree. So guys, now why we calculated magnitude and direction of relative velocity? See, this is what, this relative path is of what, guys? Relative path of second vessel with respect to first vessel. So means whatever the direction of relative path, same must be direction of relative velocity of the second vessel with respect to first. So what we got, guys, now? What we got? We got the, what we got, everyone? Everyone, what we got? We got what we got? Everyone, what we got? We got the direction of what? Relative velocity and magnitude of relative velocity. And here this relative velocity is what? This relative velocity with respect to what, guys? With respect to first vessel. So with respect to first vessel means what? it must start from this point. With respect to means what? It must start from this point. Now my question is what, guys? It is start from this point and it must be like this. My question is, it is end here or here? It end in northwest quadrant or northeast quadrant? Where it end, guys? This relative velocity, where it end? Northwest quadrant or... See, this is, see. This is what? What is meant by this one? Theta 1. Okay, so whatever the direction of relative path, same will be the direction of relative velocity, na? See, what they are saying, your doubt is what? They have not said with respect to, what is your doubt? Your doubt is what? Your doubt is what? One minute. I got your doubt. Okay, what is your doubt? In the question, what they said, course and speed of the second vessel. What they said, see, listen my words. Your doubt is what? They have not said, they just said course and speed of the second vessel. That is only they said. They have not said with respect to. Because here, why they have not said? Here, our target is what? We have to find out absolute values, na? Absolute velocity. Here, this is not our answer. See, you feels that this is not our answer. Our target is what? We have to find out absolute velocity of the second vessel, and absolute velocity is always with respect to Earth. Okay, so this is not our target. Are you getting my point? So here, this relative velocity is whatever we got, relative velocity of second vessel with respect to first. And we got this direction, this theta 1. And from this drawing, so here, now my question is, guys, this relative velocity, where it end? It end here or here? See, this direction is what? Theta 1. Theta 1 is this one. Okay, everyone. Where it end, guys? This relative velocity of the second. Okay, its value is what? 11.2126. Everyone observe this value. And what is the value of V1, everyone? What is the value of V1? 18 knots. 18 knots. Now observe the drawing. So, if it is, guys, if it is in this one, so its value must be very big, 20, 30, like that, 20 knots, 30 knots. But here value is how much? 11.2126. So it is smaller than this one. So where should it end, guys? My question. Where it should end, guys? In northwest. So it should be end here. Everyone getting my point? Try to see the scenario here. So this is what this indicate what, guys? Relative velocity of what? Second with respect to what? First. Now our closing side will be what, everyone? What will be the closing side? What will be the closing side, guys? Here we discuss, guys, always absolute velocities always starts from what? Origin. So whatever the closing side will remain, this closing side will be what, everyone? What will be this closing side? This closing side indicate what? What this closing side indicate, everyone? No, this closing side will indicate absolute velocities. And this is what our target. We have to find out its magnitude and its direction. And we consider this direction is what? We consider this direction as a theta 2. Everyone getting my point? Anyone have any doubt in this discussion, guys? Anyone have any doubt in this velocity vector diagram? Observe the things here, guys, before going further. So here, so now, guys, what is our target? We have to find out its V2 value, its magnitude, and we have to find out that theta 2. Guys, are you getting my point? Try to see the scenario here. Observe this once again. Anyone have any doubt in this discussion? Okay, guys, now before going further, we will not. So first of all, guys, give the heading of the B part. Okay, this part is not completed yet. We not got the answer. So before going further, write down V1. That is what our target means. This is given here. V1 18 knots. Okay, V1 from V1. So we got V1. It is given in the question. Then draw this velocity vector diagram. Then guys this one. And after writing this one, we will solve this question further. Okay. First of all, everyone write down this one. This part is not completed yet. So now our target is what here? We have to find out V2, its value, magnitude and its direction. So guys, how to get the V2? How to get the V2, everyone? Try to see the scenario here. So here we have a relative velocity. This is what a relative velocity. We have a V1 and we have a this θ1. Means we have an angle, and adjacent to the angle we have a adjacent side, and we want to find out opposite side, guys. So as usual, then favorite thing is what? By cosine rule. Try to see the point here. By what? By cosine rule. So by cosine rule, what will be the V2 is equal to what, guys? V2 will be equal to what? Under root of, try to see the point, under root of what? V1 square plus relative velocity square. See the scenario here. Minus 2 times V1 into relative velocity into what, guys? What will be the into? Cos of θ1. Everyone getting my point? So what will be the value of V2? Under root of V1 is how much? What is V1? 18 knots. So 18 square plus relative velocity here we calculated 11.2126. Try to see the scenario here. 11.2126 square minus 2 times 18. 11.2126 into what? Cos of θ1 4.4786. So please everyone do the calculation and tell me the value of V2. So everyone got this relation, cosine rule. Why we use cosine rule here? So under root of square root of 18 square plus 11.2126 square minus 2 times 18 into 11.2126 into what? Cos of 4.4786. How much value we got, everyone? How much value, everyone, we are getting? 6.8775 knots. Okay. So this is what a one answer. That is what a speed. Speed of the second vessel. Everyone got my point? So this is what a speed of second vessel. This is what our one answer. Now what we need? We need the course. Course means what? Direction. For the course, we need the value of this θ2. And how to get the θ2? We are going to use by sine rule. So we have to find out what, guys? By sine rule. So try to see the scenario here. By sine rule, we have to find out θ2. θ2 opposite is what? Relative velocity. So θ2 opposite is what? Relative velocity. So relative velocity divided by what? Sine of θ2. Then θ1 opposite is what? V2. So V2 by sine of θ1. Everyone getting my point? So sine of θ2 will be equal to what? What will be the sine of θ2 will be equal to what, everyone? Sine of θ2 will be equal to relative velocity into what? Sine of θ1. Try to see the scenario here. Divided by what? Divided by what? V2. So what is the value of relative velocity? 11.2126 sine of θ1. θ1 is how much? 4.4786 divided by what? V2. How much value of V2, everyone? 6.8775. Okay, is equal to what, everyone? 11.2126 multiplied by what? Sine of 4.4786 divided by what? 6.8775. How much value we are getting? 0.1273. So θ2 will be equal to what? Sine inverse of 0.1273. So everyone please do the calculation and tell me the value of sine inverse of what? 0.127.3136 degree. Okay, so therefore course taken by second vessel. What will be the course taken by the second vessel, everyone? 7.3136 degree. In which direction, everyone? This theta 2 is in between north of west. Everyone getting my point? Try to see the scenario here. Very simple discussion. So this is our answer of B part. Not that much difficult. Only difficult task is here what? The space diagram, guys. Understanding space diagram, getting the concept for space diagram is a difficult task here. Please everyone complete this point. Everyone, please complete.